In the desolate expanse of a desert wasteland, amidst the scorching sun and bone-dry winds, lives a tiny pink warrior, Deinococcus Radiodurans, nicknamed the Conan bacterium. For its incredible resilience, this extremophile thrives where most life forms would perish. But D. Radiodurans holds a secret weapon, an unparalleled resistance to radiation, 100 times higher than what would kill a human. This is the story of a microscopic marvel and its extraordinary ability to survive the harshest environments. Imagine a world bombarded by lethal rays. D. Radiodurans inhabit such a world, found in soil, desert, sand, and even the sterile clean rooms of spacecraft assembly facilities. This bacterium has adapted to endure the most punishing radiation doses. But how does this tiny organism achieve this feat? The secret lies within its multiple personalities. Unlike most bacteria with a single chromosome, D. Radiodurans boasts 4 copies. These redundant genomes act as backups, allowing the bacterium to repair radiation-induced damage efficiently. Think of it like having multiple copies of an important document. If one gets damaged, you can easily replace it with another. But the story doesn't end there. D. Radiodurans also possesses a formidable arsenal of DNA repair enzymes. These molecular surgeons can meticulously mend double-strand breaks, single-strand breaks, and other DNA lesions caused by radiation, ensuring the integrity of its genetic blueprint. It's like having a dedicated team of repair technicians constantly on call to fix any damage. However, D. Radiodurans takes a minimalist approach when it comes to its genome. Unlike some bacteria with sprawling genetic libraries, D. Radiodurans keeps its genome compact. This strategic downsizing minimizes the target area for radiation damage, making it a smaller bullseye for the harmful rays. But the fight against radiation isn't just about defense. D. Radiodurans also deploys a potent offensive strategy. It produces antioxidant molecules that act like cosmic janitors, scavenging free radicals generated by radiation. These free radicals are highly reactive molecules that can damage cellular components, but the antioxidants neutralize them before they can wreak havoc. The final piece of the puzzle is D. Radiodurans' remarkable ability to enter a state of suspended animation. When faced with harsh conditions like drought or radiation, it can transform into a desiccated state with minimal water content. This desiccated state puts the bacterium on hold, minimizing its metabolic activity and further enhancing its resistance to radiation and other environmental challenges. It's like taking a deep breath and holding it until the danger passes. The extraordinary resilience of D. Radiodurans has captured the imagination of scientists worldwide. Its potential applications are vast and hold promise for numerous fields. Imagine using this bacterium to clean up radioactive waste sites, where its radiation resistance allows it to break down harmful pollutants. Or picture it contributing to the development of biodegradation systems in spacecraft, helping to manage waste on long-duration space missions. Furthermore, studying the DNA repair mechanisms of D. Radiodurans may offer insights into developing new strategies for treating radiation-induced damage in cancer patients. The enzymes employed by this bacterium could potentially be harnessed to improve the effectiveness of radiation therapy while minimizing side effects. However, The journey of unlocking the full potential of D-radiodurans is ongoing. Further research is needed to fully understand the intricacies of its radio resistance and explore its applications in a safe and controlled manner. Ethical considerations also come into play, as ensuring biosafety is paramount when dealing with such a hardy organism. Deinococcus Radiodurans serves as a testament to the tenacity of life and its ability to adapt to even the most extreme environments. It pushes the boundaries of our understanding of microbial survival strategies and offers a glimpse into the remarkable resilience that may exist elsewhere in the universe. As we delve deeper into the secrets of this Conan bacterium, it's likely to continue surprising us and paving the way for advancements in medicine, space exploration, and bioremediation.